Thank you, Ian. Thank you, Nancy, for the introductions. And thank you very much to all of you for the invite this afternoon to talk about CIP process and flavored carryover. So basically, just a quick history. I'm working on the brewery industries. I start working in the brewery industries in the 1984. So it's been like 36 or 7 years this year that I'm going to work. And I begin for the 13 first years of my brewery industries workers to be a brewers and employee brewers and doing tank washing through operating filters and working in the brewing area for a large brewery here. I'm living in Montreal, Quebec. And so I start like this, and I had the chance to work for Ecolab and going to very nice support at Ecolab and trainings that conduct me to be a brewing specialist and looking over all the Canadian brewery and supporting guy like Ian Crook. That Ian don't need a lot of support. He's one of the best in Canada. And yeah, I'm supporting all the Canadian brewery from the larger one to the smallest one that need our help and involvement. So that being said, it's me, yes. So today, with all the upcoming, when I start my 35 years ago, we had basically Molson Export and Brador and Labatt 50s and quite small brand of beers, and that was in the market. So light beers and not a lot of strong beers, or not even think about getting some beers with flavored. So a lot of change. So now it creating new challenge, and one of that challenge is really the flavored. So we will talk a little bit about the parameters of the cleanings, how the flavor is migrating and coming back to the next batch that you're doing. And this is what we want to avoid. And the 3-step cold cleaning, I will coming back for those who was in 2019 in Calgary for the MBAA. I know that Ecolab did one, it was really the launch of this, and it was kind of a baby for us, that 3-step cold, and now we're getting more and more, and it worked very, very, very good. And we will talk about that because it's working as well for the flavored carryover. So on this one, what is how the flavored carryover is a result of? First, three problems will come in with that will bring flavored carryover. So first one will be residue or of content on the surface. So basically that your CIP is not working properly. So it's a CIP problems for sure. You will get it's not cleaned. It will bring this. So this is not really what we will talk today. But if you're starting from that point, you need to resolve those problems. But the second one will be a little bit more complicated. It's again the CIP problem, but residue that will be when I'm saying the contaminant in that I'm talking about flavored in this presentation, but it's getting in inaccessible area in the system. So it could be dead legs, crevice, edge, corner. We will see some. And the third one is the most challenging one, is really the migrations and the remigrations on the surface that you are cleaning. So let's talk with the first about the cleaning, because if your CIP, even if you're thinking about products, or even if your CIP is not properly set up, we're going to have some issues. And I'm talking here basically about the mechanics. So when we're talking, we're talking about a CIP, we're only referring to the 4x4. You probably saw it as a pie chart saying, the 4 parameters: time, temperatures, uh, um, chemical concentrations, and the mechanical actions. So on the mechanical actions here, this is one of the biggest problem issues on flavor carryover. If you're not reaching out to all the area that you want to clean. So I'm saying here that the higher the mechanic is, the higher cleaning effect. But for sure, there's some limit to that design, the construction of the line, the mechanical stability of the line, we cannot over pressurize or whatever. And as well, more in, if you're talking about tank washing, uh, possible foam. So let's say we want to get a huge pump. It doesn't mean that it's going to resolve that. That's what I'm basically saying here. We need to get the appropriate mechanical actions. So if I'm coming here, let me go back so the video will work. So here's, let's talk about what's happening in a flow. So if you're looking on the top one, I'm talking about a laminar flow. And a laminar flow, you're seeing that we have a red dye that we are injecting in the flow of a pipe, and that dye is not even it's not mixing with the water. So just imagine that you got some detergents that you are in your pipe, and nothing. Basically, the side wall of that pipe is basically soaking. It's not getting a flow because the flow first will go in the middle, because on the side of the pipe you got some resistance. So if the flow is not enough to push the sidewall, it's going to go through the middle, and you're not going to see any mechanical action. It's just like soaking your pipe. You're not going to do anything more. So when at a certain point that we will review how at the next slide, but if you are achieving the right flow, you will bring that turbulent flow. So, I'm comparing that just like a huge car accident that you have on a highway, that many cars will come in, that the side one will, one car is going and they're all smashing together. And basically this is what's happening in the water. You can see that red dye, that it's kind of mixing, it's going all over the place, and that water will make some impact on the sidewall of your pipe and will clean it. So how that things it's happening, I'm looking really bright by bringing all those physics rules, but I never calculate all this, but I like to know where it's coming from. It's not something coming from Ecolab or from, any, it's really a physics, it's in physics, and we call that the Reynolds. And, basically it's the size of the pipe and the flow speed. And by achieving a flow speed, with that calculation of Reynolds, higher, what we're seeing here, it's higher than 1500 on your result, you will create that turbulent flow. So, but the rules, of thumbs here, I got it in meter per seconds. But if we're talking about a pipe smaller than 3 inches, we're talking about 1.5 meter per second, or 5 feet per second. So just calculating the volume on the 5 feet, and if you got like 100 gallons in 5 feet, this is what you need per seconds in your, not 500, but you got a certain amount of volume. This is what you need per second, okay? Let's say you got 1 gallon, you will go to 60 times per minute to bring that per minute. And this is the flow that you need to achieve. your flow to get some turbulent flow. So another quick video on the mechanical effect. You can see that if you're not achieving your flow, here we're at 0.3 meters per second, so it's 1 feet per second. You can see that the soil, I don't know if it's beans, corn, or whatever in there, but you cannot clean it. It's stay there. You know, it's hard to move it on the wall. Now we're at 3 feet per second. And now this is 1.5 meters, and so mean 5 feet per second. You see that now you're creating a complete mechanical actions inside your pipe, and all the beans that we're seeing in that pipe it's removed. So just on the particles and the cleaning effect, I bring that slide here saying, hey, bigger your soil will be, or more it will be in the middle of the pipe, more flow and more action that they will get. And here, I just want to bring this to say, hey, how it's important to get that turbulent flow at the right level. That we're talking now about microscopic size of soils. When we're talking about flavored, we're talking about flavored molecules. So this is what's going to happen when you got some flavored products. It's not the gross soils or the big soils that you will get by beer. It's really a flavor. It's a smaller one. Again, when you consider to understand, if you've got, let's say, hoses and pipe, and consider always the larger one to get your turbulent flow, because from a large one you get a turbulent flow, and you're going to a smaller one, you will still get a turbulent flow, as that smaller one will be even higher. It's going to go faster in the pipe. But the opposite is not true. That if you're in a smaller one and you're going to a larger one, now you will get that linear flow inside your pipe. It's happened. I'm doing a lot of audit and troubleshooting, and I can tell you that many area that people will add on their process, and they will add a sensor, a flow meters, plenty of different equipment that you can add, and it's going to be like only 3 feet of pipe, but they will be on a 2-inch or a 1.5 or even 3, and they will be a little bit better in that, bigger in that area. And what's happening in this area, and you will get a sensor, gasket, all harder place to clean, because you will get some shadowing, and you're coming, the flow will be slower, not turbulent, and you're just soaking, and you're going back and getting that action. So that could be some area that you will get some micro issues, and we're talking here about flavor. It's even I should say I think it's more hard to get rid of the flavor sometimes than a micro. So think about that. We're talking about same size of challenge. Okay, so you calculating always the biggest or the hardest part that need the higher flow, and this is what your flow should be. Typical mistake when you got a T, dead end, dead legs. The rule here is basically the parts, the pipe, that it will be, you know, let's say you got a T here, and this one here is cap. The diameter of this one, okay, it should never be longer. If it's longer than 1.5, the diameter that you have of that pipe, okay, you're in trouble. You are in trouble. And so if it's below 1.5, it's not ideal, but better. But I'm going to add one statement in here. If you are achieving the proper flow, okay? So if you're lower a bit in the flow and you got this, it's not true. It's not going to be clean. Another considerations that I'm talking with all brewers in here, and if you considered doing some new equipment or installing censored, please consider always to request all your connections as much as possible, censored on the side of the pipe, not on the top and not on the bottom. The bottom is a little bit better. This is the worst one. This is, we can live with it, but this is the best in class most of the time. Okay, it's easier to clean. And so if you got to consider tangential installation on the side will be the best. The surface roughness of the stainless steel and size, I'm saying micro in here, but it's exactly the same for flavor. Especially, I'm saying, you know, we got all kind of stainless steel, all kind of finish. So if you have one and you don't know, but if you consider buying some, take a look of what is your finish, because it could be, okay, the roughness of your stainless steel can be an arborage for micro or flavored. As you can see that there's a few different roughness of stainless steel, and basically, you know, the red, the green, and the blue, it's bacteria, bacillus, yeast, or mold spores. So it can be an arborage. So that feels like one of my colleagues in Germany did a very nice pictures that he put his business card on a stainless steel parts, and he take that stainless steels and he went to the microscope to showing on the right side what it's looked like. So to tell you, this is not completely, it's not a glasses, okay? So, and there's difference in the stainless steel. So please consider when you're buying, especially if you have to buy and the products and the sensibility of what you want to do, consider and just be aware that it can create some issues for you when you're going over there. So the equipment conditions, so for sure, if you got some add-on, well, you know, this is not, you know, on the top corner, left top corner, this is not ideals, but I'm seeing this on some tanks that they repaired, some gaskets that you can see, door gasket, even a tri-clamp gasket. And don't think that this tri-clamp gasket that you can see in the bottom left corner, that it's really some things that it's hard to find. You know, I'm doing like, I don't know, probably visiting like 50 different breweries per years, and I will probably on every 5 breweries or 4 breweries, I will get some micro issues and finding some, forget a gasket that it's installed since, I don't know, 5 years, 15 years, and some are there for 20 years, you know. So this is what look like if you're not doing a good job to looking at your gasket. And you'll see when we will talk about the material and the absorptions, just imagine on the flavored, what's going to happen with that kind of gasket. Hoses, you know, look at your hoses, the conditions of your hoses. This could be a really hard, a place that could be harborage a lot of flavored and as well as micro. Good procedures, cleanings, and I'm just getting my 2 minutes of health and safety. Don't do like what you're seeing on that pictures. Please put glove if you are using chemical. So that's basically talking about what can happen on just on the mechanical. We're not talking about nothing serious, not serious, but nothing about really the flavored and the migrations, why it's hard. But this will be completely harborage for your for the flavored as well as the micro. So on now, let's talk specifically on the flavored. What's happening to those flavored when it's going in your specific tanks or all the material of your process that those flavored are in contact. So here's my explanations of what you're seeing here. The gray area that's saying material, just imagine it could be a gasket, a surface of a gasket. It could be a surface of stainless steel. We'll talk about what is the difference and how deep all that will come in with different material on the later slide. But that gray zone right now is your material. And the solution with contaminant, I should, this solution will be beer or with flavor. This is the contaminant that we're talking in here. So we're initiating a contact in a tank or in a filler, in whatever equipment or process that you have. And so at the step 2, what's happening, that now that they are in contact, something's happened called the migrations. So basically, the material will absorb. And this is not like micro. We're, for the first slide, we were talking about just like micro and saying, oh, the flavor can stay where micro. But now flavored it can be absorbed by material. So we call that a migration. So that flavored will migrate inside, and on the step 3, we getting more longer that it will be in contact. I'm comparing maybe a hose or versus a tank or in a gasket, a door gasket on your tank. The hose probably will be clean right after, but and so it will go there probably 30 minutes or an hour, the time that you're filling your tank. But your gasket and the on your tank, that it will sitting there for, I don't know, 1 day, 24 hours, a week, 2 weeks, I don't know, all depend of your process and how you handling and how you doing, but longer that it's going to be in contact with flavor, more that migrations will go deeper and coming in contact with the surface, with the material itself. So at the point, it's going to be the end of the migrations that you will empty your tank, and you will just getting on the top here, it's just the material, and that material will be basically absorbing and will keep that flavored inside that material. So now we want a cleaning. So during the cleaning, and what's going to happen, the migration will continue, but it continue on the opposite side. So now your material, the flavor in your material, want to go inside your solutions. Okay, so we have a remigrations, and just keep in mind that the solution won't migrate inside any chemicals it's not going to be absorbed by the material, because if it's, just think about it, if you absorb caustic or whatever, or acid or anything, that you will keep some acid in, it's going to be a sponge, and you don't want that. You know, it's so the cleaning solutions is not going to be absorbed by the material. So we're cleaning the surface, and we treating that surface, and we want to remove that flavor from our solution. This is what we will talk about this a little bit later, but we're just cleaning. So we want to that flavor remigrate inside the cleaning solutions. So after cleaning, as you can see in the illustrations, the third one here, that on your surface, you know, you're coming back to gray, because, you know, you absorb, the solution absorb what the material want to migrate to the solutions, but you still got some flavored that it's in your material. And after the cleaning, when it's sitting, that flavor inside will be diffused. Okay, so basically it will be, you know, it will be diluted or diffused in your material. So the flavored will coming back at the lower concentrations, but it will coming back to the top of your surface. So what's happening now, you're going to refill that with, I don't know, if you're refilling with another flavored or the same flavored, it's not an issue. But just think about if you're filling and you want to do some water, just water, you know, you will get, or a light beers, or you know, sensitive, you will captured. Now what's happening, you will absorb that. It will be a diffusions, not a diffusion, of the migrations that will continue to your next beverage. And this is where we have a huge challenge in the industries, and people call us and say, hey, how I'm going to rid off that flavor. Okay, so that kind of reviewing how the process is going. So now let's talk about material. So we did a lot of the I've been in contact with our R&D in Germany that running many tests, and those tests have been done to one of our R&D facility in Germany, and basically they are kind of creating an index of the migrations. So if you are seeing higher that you will be, so higher you will get. The blue one is the smell, and the purple one, let's say, I don't know which color, but it looks purple, is the taste. Okay, so it means that they put some water probably in contact, and they are smelling the parts, and they are tasting some water to see if we got some pickup of that flavor. And FKM, more known as Viton, you can see that we have pretty high pickup. PTFE is Teflon. I apologize, I don't know what is XP40. I'm doing an assumption that it's probably silicone, but I'm not sure about it. So if somebody know it, just letting me know on the chat. I make a few research and I didn't find it. And EPDM is probably one of the common gasket, you know, the black gasket EPDM, and this is you know, that index is pretty high on EPDM.
Sorry, Denis, sorry to interrupt here. It's Ian here. Yeah, we're a little bit over time already, so just wondering if could you just jump ahead to the best CIP practices and the 3-step, and then hope to wrap up by 2:45.
Absolutely. At when?
Yeah. I know you're passionate about CIP, but yeah, I think it was supposed to be done by 2:30, and then 2:45 was Q&A. But if we can wrap up in 5, that'd be awesome.
Yeah. I don't have a lot. We're going to 3-step cold right after.
Okay. So, great.
Okay. Thank you for the. Yeah, I'm just saying. Okay. So stainless steel migration's pretty low. This is the last one about the what's happening. We did run some trial cold water to see. This is the 3 column is 3 different flavor that we made some trial, and you can see that higher than the column is higher that we will pick up the flavored, and lower it is, lower that we will remove the flavor. So cold water, it's kind of the highest, it's not doing a very good job. Caustic, blended caustic, we're seeing that it worked on some flavored, okay, but some others, it's not pretty good. We did at 80 degrees C, this is really hot. At 45 degrees C, we put some caustic with 2 different oxidants. So oxidant number 1 and number 2 is quite the same. And we did run some trial as well with caustic with oxidant at 80 degrees C. And this is where we have the best results. And as well, we went with water at 80 degrees C. So by this, if you want to review and talk more about, we will coming back as we're running out of time. But the parameters to that make what we can conclude on this is, with temperatures and time, for sure that we will help us, but increasing the solubility in or by the cleaning media, this is how we will achieve some, and oxidizing will destroy the flavor. So by eating the caustic, it's more soluble. And as well, that when we're adding some oxidizer, this is what is really killing the off flavor. So that brings me to the 3-step cold. And basically, I don't want to go through maybe all those slides, but again, this is the 3-step cold that I am talking here. This is an innovations on the market. And since let's say 2 years, but it's still the teenagers in the market, and we're discovering that we are recommending to do a 3-step cold in clean beer area, and that works. So Synergex is a parasitic clean sanitizer, but as well is a complex one. It's a peroxysulfonate oleic acid known as PSOA. And this product's got some claim to be a sanitizer, but as well, we can use it as a cleaner. And we did a lot of trial, but now it's not even a trial. It's just a very nice procedures that we're using for bright beer. For sure, we need some validations in your process, but what we're discovering, and we're working closely with beverage industries as well, that by using that kind of products as a 3-step cold cleaner, we are removing a lot of the flavored that can be possible on challenge, and we have a lot of good stuff. A very good result, as well as the 3-step cold, for sure, that just think that you don't have to do any washes time anymore, or or eat it if you were eating some caustic solutions or even acid, you don't have to do it, and could be just pre-rinse, washing with that cleaners, sanitizers, and just rinse it, and we are ready to go. And it's a very, very good practice to remove Flavour. So we can probably, I got pictures, but basically it's what we did. It's soiled, it's our positive controlled, and what our experimentals, this is what ability our R&D folks from St. Paul present last year's, and equal products, or even betters on as an acid wash, no visual buildup, and we did some analysis of water, of the rinsing and the wash solutions, that's showing that we are removing the soils and keep all the minerals out of the out of the tanks, and by washing. Sorry, I did like running, and I'm running in English right now. So, so
that's
questions. So she wanted. I think question is kind of the best part of the presentation usually.
Yeah, that's perfect, Denny. Thanks for that. You can tell obviously that Denny is pretty fired up about CIP and cleaning and that kind of stuff. So yeah, he and I have worked together a number of times all across Canada, and definitely we like to drink beer and talk about cleaning. So I guess really the nut of it there was as brewers are getting into more flavored beverages and doing RTDs, the benefits, especially of RTDs, is that you can turn your tanks over quickly. But CO2 loss and heat and flavor migration all being considerations. So the Synergex is a great solution for that. I've got a few of the larger micros out here in BC that are starting to use that now, and I actually had some discussions with them last week about this exact thing. And for sure, the flavor migration is a concern, and yeah, the Synergex works great. It's basically hyper acidified paracetic acid with the sulfonic acid added to it. So yeah, lower pH, more acidic, and does a great job on the flavor. So yeah, just looking at the questions there. Yeah. Are you seeing these, Denny? They're asking if they can eliminate the acid washing. Yeah.
Yeah, I'm seeing some, but yeah. But if you had the time to read it, Ian.
Sure. Yeah. They're asking, can we eliminate acid washing if we're using Synergex?
The answer on the bright beer, in most cases, if you got to appropriate all your CIP is set up properly. Currently, we have very good result, and I will not lie that in some beers or we need to validate. But I should say that 90% and maybe more than that, it worked very good. Very good.
Yeah, the point I'll add to that is that the use pH of the Synergex is just under 2.5, and that's always for us. That's always the magic number of getting below for your acid washing to be effective. I have a cheese plant that uses it, and they're able to get away from acid washing throughout the day on their vats to prevent sticking by use of Synergex. So yeah. Yes, you can certainly reduce it a great deal. So. So one of the questions was on the pipe size, Denny. When understanding it's not ideal to go from 3 to a 5 when you're increasing your pipe size by adding equipment. What is the best cleaning process for this kind of situation?
Okay, so for sure you need the flow to clean a 5 feet per, for a 5 inches. So you want to bring it. And if you don't have a pump, and honestly now I don't know what the size of the brewery, and it could be done by creating a side loop. Let's say if it's only a small parts, or we're doing that for heat exchangers or different situations, but you need to take your 5. The best practice will say, oh, you got some 5. I need to run at the flow to clean 5 feet per second in the 5 inch. not even, it's going to be 7 feet per second, because if you're bigger than 3 inches, we recommend 2 meters per second. That is 7 inch per second. Yeah, 7 feet per second.
Yeah,
sorry.
Perfect. Yeah, I know, like just from what I've seen in the breweries around, certainly around Western Canada, starting out relatively small and having success, and you know, starting out with 10 hec fermenters and then installing 50s and moving up to hundreds, and of course things go from 1.5 to 2 to 2.5 to, you know, larger, and that's all great, and your local stainless steel welding guy will be happy to connect those pipes together, but it's definitely something you got to look out for when you're changing pipe diameters, and you got to increase supply pumps or go back and enlarge smaller lines. There's some engineering around that, but again, that's kind of stuff that we like to help you out with. Denny, here there was one question. Can you expand on the stainless steel finish, including an RA value if possible? I think that was the one slide you had that showed a bunch of different stainless surfaces. I think those were just different polishes, but can you expand on a stainless steel finish, include an RA value if possible?
If you want me to bring what is the best one, I don't have the answer, honestly. I know that the RA value, it's really the roughness and the basically the shine, the finish on, and that R will be kind of there's you can make some research quickly on the web. And I don't have it by heart. I apologize that bringing that in my presentation. I should have the backup on me, but this is kind of, I think it's higher that the numbers will be, it's rougher, it will, and basically glasses and perfect finished with nothing will be a kind of R1 or R0 or something like that. So,
perfect.
So it's really the quality of the finish. But if you're going, let's say, on stainless steel 316, if you have to buy, it's going to be on your quote if you're looking, and right. You will see the difference in the pricing.
Yeah, I think probably the last one before we turn back over to Nancy in a minute or two here. They're asking about whether CO2 is effective while CO2 is present. Can I clean a bright tank under pressure with Synergex without losing my purge? Yeah, the answer to that is absolutely, and again, that's really at the heart of why the 3-step cold is so appealing. Is that you don't have to purge your bright tank of CO2 and then heat the tank, use caustic, partially neutralize that caustic, and then, you know, buy more CO2 to have to repurge that tank, which you never really get completely out. So yeah, do an acid wash and acid sani under pressure or even atmospherically, either way, definitely helps speed up the turnaround, saves you energy, saves chemicals, and prevents reintroducing oxygen, which turns out to be not good for beer. So yeah.
Just a little clarifications when we're saying under pressured, and that questions came to me very often, and I want to. It's under pressured or under a CO2 atmosphere. For me, it's different. Okay, under CO2 atmosphere, you're going to remove the pressure, so that usually 10, 12 pound of CO2 that you have on the bright beer tanks, you will kind of removing the pressure, and you're not removing the CO2, and you start your cleaning, and that is on the CO2 atmosphere. And can we wash under CO2 pressured? That is possible as well, keeping your 10, 12 pound. But at this point, you need to review some mechanics on your return if you're washing a tank, because what's going to happen, you're going to create a lot of bubbles in your CIP. So you need a special valve when no liquids go in, that valve will close and you keep your pressure in your tank. And yes, that is possible. I got a lot of customers that doing this to save completely their CO2, and they're under pressured all the time.
Great. Thanks so much, Denis and Ian, both for reminding us of the necessities of doing proper CIPs and shedding light on a flavor problem that a lot of us don't think about. I just want to know where you guys were 20 years ago when I was sitting out in Siberia trying to figure this thing out. But so really great information, today. For everyone, we're going to take a brief break, but we're going to start again at 3 o'clock. So the good news is you don't have to stand in line for the washroom here. See you at 3.